Good morning. Today we will start comparison of Otto, diesel and dual cycle. The important variable factors which are used as the basis for comparison of these cycles are compression ratio, peak pressure, heat addition, heat rejection and net work. In order to compare the performance of Otto, diesel and dual combustion cycle, some of the variables must be fixed. In this section, a comparison of these three cycles is made for the same compression ratio, same heat addition, constant maximum pressure and temperature, same heat rejection and net work output. This analysis will show which cycle is more efficient for a given set of operating conditions. So first we will start with the first parameter, which is same compression ratio and heat reject addition. So you can see here in the PV diagram 1, 2, 3, 4. This is your Otto cycle. 1, 2, 2 double dash, 3 double dash, 4 double dash, 1. This is your dual cycle. 1, 2, 3 dash, 4 dash. This is your diesel cycle. In the TS diagram, you can see here this 1, 2, 3, 4. This is your Otto cycle. 1, 2, 2 double dash, 3 double dash, 4 double dash is your dual cycle. 1, 2, 3 double dash, 4 dash. This is your diesel cycle. So in this case, condition is that compression ratio and heat addition should be same. So heat addition we will see in TS diagram, compression ratio we will see in PV diagram. You can see the initial state 1 is same in all these three cycles, whether it is a diesel cycle, whether it is a dual cycle, whether it is a Otto cycle. So one part is same. So 1 to 2 is compression ratio. So 1 to 2 is your compression ratio. This process is same as we had seen, same compression ratio. So 1 to 2 condition is same. Now heat addition is same. We will see in TS diagram. You can see in TS diagram area 5, 2, 3, 6 is equal to area 5, 2, 3 dash, 6 dash is equal to area 5, 2, 2 double dash, 3 double dash and 6 double dash. So heat addition is same, amount of heat supplied is same. We are not talking about heat rejection, we are talking about heat addition. Heat supplied in this cycle, heat supplied in this cycle and heat supplied in diesel cycle. In these three cycles, heat supplied is same. You can see from this area, heat supplied in this cycle, heat supplied in dual cycle, heat supplied in diesel cycle is same. All the cycles start from the same initial point 1 and the air is compressed from state 1 to 2. As the compression ratio is same, it is seen from TH diagram. For the same heat input, the heat rejection in Otto cycle is minimum. Now heat supplied is same. So what will be the criteria? Heat rejection. We will see in which case heat rejection is minimum. You can say this line 4 to 1. This 4 to 1 in Otto cycle is less as compared to 4 dash and 1, and 4 dash 1 is the maximum heat rejection. You can see 4 dash to 1 it is maximum heat rejection. So in case of diesel cycle, this is your diesel cycle. In case of diesel cycle, the amount of heat rejection from 4 dash to 1 is more. In dual cycle, in case of dual cycle, the amount of heat rejection is medium, and in case of Otto cycle 4 to 1, the amount of heat rejection is minimum. You can see this is your Otto cycle, the amount of heat rejection is minimum. So you can see here Otto cycle has minimum heat rejection, diesel cycle has maximum heat rejection. Amount of heat supplied is same. Amount of heat rejection will decide which cycle is more efficient and which cycle will produce more work. So Otto cycle will produce more work as compared to dual cycle, and diesel cycle will produce minimum work because heat rejection in case of diesel cycle is more. So in case of diesel cycle, heat rejection is more, so amount of work in diesel cycle is minimum. In case of Otto cycle, heat rejection is less, so amount of work produced in Otto cycle is maximum. And same for the efficiency, because heat supplied is same, amount of work is heat rejected is different, heat supplied is same. So if you divide this term work by amount of heat supplied, you will get efficiency. The same, you can say same is the here for efficiency. You place work by efficiency, work by efficiency, work by efficiency, you will get efficiency of Otto cycle is more than efficiency of dual cycle, greater than efficiency of diesel cycle. So this is the comparison when your compression ratio is same and amount of heat supplied, means amount of heat supplied to these three cycles, whether it is a Otto cycle, whether it is a dual cycle, whether it is a diesel cycle is same. So this is the criteria. So this is your output. Work output for Otto cycle is more as compared to dual, as compared to diesel cycle.